In one of my last videos, I showed you how I built my new home server with Proxmox, which is an amazing system to run virtual machines in your home lab. And Proxmox is great as a hypervisor. You can build ZFS storage pools with it, you can run virtual machines, but it isn't really great for storing files and making them available in your network. So I was searching for something else that I could use as a NAS system. And I wanted to run it as a virtual machine because then I could just use my existing server without buying a new device. So I did a quick research on the internet and I thought I should try out TrueNAS and run this as a virtual machine in Proxmox. Turns out that this isn't actually so difficult and there are no bigger downsides when doing this, but there are still a few things you need to consider when building a storage system on desktop hardware or run it as a virtual machine. So let's take a look at these things and let me show you how I built this system. By the way, thanks everybody for supporting my channel. I'm so thankful for all the great people in my community. May it be on Discord or on Twitter. You're always giving me such a great feedback, interesting questions and great suggestions for future videos. And I know that I haven't really delivered on that like I wanted to in the past, just because there's so much I want to do with this channel and there are so many topics and tools I want to make all videos about, which can be overwhelming. But I will keep track of all your suggestions, and if there is something in particular you really want to see or you need help with, then please let me know. I may not be able to cover everything and turn it into an interesting and appealing video, but at least I try. I try really hard. Anyway, I just wanted to get that out of the way, so let's start with the server build. And I first want to show you TrueNAS Core, which was previously known as FreeNAS, and this is an operating system based on FreeBSD, which comes with many cool features like an intuitive web UI and a redundant software RAID that is based on OpenZFS, and you can just download this on their homepage completely for free. You can install that on a desktop PC or server, but also run it in a virtual machine. And for any professional company environment, there's even an enterprise version existing that comes with some additional cool features. But for any home server, the TrueNAS Core version is totally sufficient. You can do everything with it that you can imagine for building a reliable storage system at home. But speaking of reliability, it is very important that you consider a few things when building this. And the first one is that you should always run TrueNAS with ECC memory. ECC stands for Error Correction Code, and it is a specific type of memory that can detect and even correct errors. It's a standard in any professional server or workstation hardware, and you can easily spot these memory modules because they are called registered ECC memory. But this is something that isn't very common on desktop hardware, because usually on a normal desktop PC you don't need that. So when you're building your TrueNAS system on professional server hardware where you have registered ECC memory, you are fine. But when you're building a home server with desktop hardware, you usually don't have ECC memory, and that could potentially get you in big trouble. Because when you're using a software RAID system like ZFS, what you will do when building a storage pool in TrueNAS, the errors in the memory can have a high impact on the integrity of the file system. And it's very hard to say how likely those errors will happen. I personally never had issues with that, but like everything in IT, things can go wrong, and if something damages your file system, without a backup you don't have any chance of rescuing your files on that storage pool. So in my last video about my home server build, I talked about this and I showed you some memory modules, the so-called unbuffered ECC, which are supported by some specific consumer CPUs and mainboards. Most likely all AMD Ryzen processors can handle ECC mode. And if you want to learn more about this, I've put you a link to my video in the description down below. There I talk in much more detail about my home server build and why I have decided to go with certain paths. And when you want to buy ECC memory for your NAS server, then take a look at my kit page where I share all of my PC and server builds which I've done and I also will do in the future. The second thing that you need is a storage controller, and which one is depending on the storage capacity you need. So most mainboards come with a built-in SATA controller, which can manage 4 to 6 hard drives usually. And if you need more drives, you may want to add an additional PCI controller. I know many people will start looking for RAID controllers, which is very common, but here's also something you need to consider that's very important. So in the case you need an additional controller card, you can go with 2 different solutions. The first one is you just get a PCI controller card that has no RAID mode and no intelligence, because then you could just pass through the individual hard drives to the operating system. And the second solution would be that you can still get a RAID controller, but only if it supports the so-called IT mode, which bypasses the RAID intelligence and simply passes through the hard drives to the operating system. But be careful, some controllers need to be flashed with a specific firmware to enable the IT mode, so make sure you're doing a good research and try to find out if the storage controller or the RAID controller you will get will work with ZFS. The installation of TrueNAS on Proxmox isn't very different from any other installation. You simply just go to the official homepage and you download the ISO file of TrueNAS. Make sure that you're selecting TrueNAS Core, which is the community and free open source edition of it. And then in Proxmox, you simply just go to your local storage where you store your ISO files and upload it there. So I've already done that. You can see the ISO file here, and let's create a new virtual machine in Proxmox. And because I already have a production system running, I will create a second one to just walk you through the process, and I will call it TrueNAS Test, for example. So let's click on next, and here we now need to select our ISO file we want to do the installation from. All the other settings like the guest OS, the Linux kernel version can be default. Also the system settings you usually don't need to touch here. And at the hard disk section, we now need to create a virtual hard disk. No, this is for the operating system. This has nothing to do with our storage pools or where the data is stored for our network later. This is just for the operating system. And as I said in my previous videos about my home server build, this should be always stored on an SSD or better on an NVMe drive, which usually gives you much better performance, right? And on my main Proxmox server, I have an NVMe drive where I have my local storage LVM volume. So this isn't actually very big, but it's totally sufficient for storing just the operating system of TrueNAS here. So I will create a new disk file of 32 GB. This should be totally fine. I don't need to cache anything here, and I just want to go next here. So now I want to add one more core to this virtual machine. I would recommend you to go with at least 2 cores here. And also the memory, TrueNAS recommends at least 8 GB of memory, better more, the larger your storage pools are, because ZFS is a very memory intensive file system. It does a lot of caching and calculations in the CPU in the memory, so you want to add more memory to it. That will definitely speed up the whole system. So 8 GB is the minimum size that is recommended, and I always forget the right size of 8 GB, so I will just calculate it and put this number into this field here. So now, if we have that, we can go to the network connection, and now that's depending on your setup, how you have set up Proxmox and how you want to connect the virtual machines to the network. You can see I have 3 network card interfaces, 3 bridges. One that is bridged to my physical network, the second is just for my internet connection, and the third, the DMZ, is routed through a Sophos XG firewall. Is also running on my Proxmox server. By the way, this will be the topic within the next couple of weeks. I will make a video how to protect your home system with a firewall. So now I want to just bridge that to my local area network. I don't want to add a VLAN here, so I will just confirm this. So now before you start this virtual machine, you want to edit a few things, because as I said, we need to pass through our hard drives or the storage controller, depending on what you got and built into your machine. So when you go to the hardware, you can also add another one here. And if you got a PCI controller card, you can just click on Add PCI device, and you can select it here and pass the whole controller through. So because I have a built-in controller on my main board, you can only see I have the NVMe drive here, but I can't pass through the internal SATA controller of the main board, because this is not an additional PCI bus. This is built into the main board. So if you don't have an additional controller and you have connected your hard drives directly on the main board, you cannot use this method here. You need to add a configuration file inside Proxmox and add those drives manually. But don't worry, I will show you how to do it. It is not actually so difficult. So first of all, I will need to connect to my Proxmox server. So I will open a new SSH connection. And then we need to find out the unique identifiers of these hard drives. So now we can use the Linux tools to find out that. So the first one is the lsblk command that will show us all block devices that are connected in the Linux operating system. And you can see that I have my NVMe hard drives here, and I also have my 3 hard drives where I want to store my data on. And these are connected to the SATA controller of my main board, so usually they start with SDA, SDB, SDC, and so on. But no, we don't see the unique identifier of these hard drives, and Proxmox doesn't recommend to refer to those hard drives via the SDA, SDB, and SDC, because those things can change once you reboot the system or you change something in the hardware. Those SDAs, SDBs, SDCs can be in reverse order, for example. So in order to always have the same integrity of the file system and always have the same way of connecting those hard drives to the virtual machine, you need to refer not to the SDA, SDB, but to the unique identifier of the hard drives, because every hard drive has a unique serial number, and we need to find out this first. And we can do that by expanding the lsblk command via the -o parameter and add the model and the serial here. So when we hit enter, you can see that this will print the same output, but it adds the model and the serial number at the end. You can see all the 3 hard drives have the same model, but they have a unique serial number. And this unique serial number is also mentioned in the device folders of the Linux operating system. So in the virtual file systems where the Linux kernel makes the hardware devices available to us, we can actually see those unique hard drives and refer to it. So when we do an ls command on this folder here, the /dev, where all the devices are stored and made available, and we can go further to disk and let us search by ID. So now we can access all the devices by a unique identifier. And you can see that all the SATA drive usually start with ATA, and then you can see the specific model of the hard drive, and here we have our unique serial number. So now we can simply just copy this path here. And now we need to add all 3 hard drives and start attaching this to the SCSI controller. You can see in the virtual machine that we have an SCSI controller where we can attach those hard drives to. And we have one SCSI 0 port, and this is used by the virtual hard disk, but we can also add other SCSI ports like SCSI 1, 2, 3, and so on for each hard drive here. And this is what we can do with the command qmz. And now we need to use the unique identifier of the virtual machine. This is a number in front of that name, in this case 103. And now I want to add an SCSI port 1. And now I can use the dev disk by ID folder and just copy this part here and add the first hard drive. So let me just do that for all hard drives as well. And now when we refresh the UI, you can see that all the 3 hard drives are now connected to the virtual machine. So this is probably not the most elegant way of doing it. I would always recommend you to add an additional controller card to your server. This will make things easier, and you always have the ability to see the controller card inside the TrueNAS virtual machine. But this is also a way how you can make it work when you don't have an additional PCI slot to add a controller card. For example, you don't have enough space, or you just don't want to spend your money on a controller card. And now we want to start the installation of TrueNAS. So what we can do now is we can simply just start the virtual machine, and let's go through the installation procedure. And this is the installation menu. We simply can just proceed and select OK. And now we want to select where we want to store our operating system on. So select the first one here, the 32GB virtual hard disk. Click on OK and confirm that. You now need to add a strong password here, of course, or you want to authenticate to your server. And now, depending on your BIOS or UEFI settings, usually by default it should be BIOS. You can see that in the hardware section of the virtual machine. If it has default SEA BIOS, you need to select this one here, otherwise the system wouldn't boot. Okay, so the system is now booted up and everything should be ready now, and we can simply connect to the web interface, or you can use this menu to configure the network card interfaces or add the NAS server, whatever you will need. And this is a web UI of TrueNAS. So now we need to authenticate with the root user and our password that we have just set up during the installation procedure. And now this is a dashboard of TrueNAS. So I think this really looks great, and it is a very simplified system. It is very intuitive to use. So the first one I want to do is add a storage pool. And because I used this on my other production system already, I can simply import the same storage pool. So when for whatever reason you delete the virtual machine, but you still have the hard drives, you can simply just pass them through to another virtual machine and import an existing storage pool. Or if this is a completely fresh new system, you can create another one. Just to show you how it works, you can simply add all the hard drives, and then you can add redundancy to a larger pool of physical disks. So in my case, because I already created the storage pool on another virtual machine, I can simply now import an existing pool. And once you have created your storage pool, you can see all the metrics here, like the used, the available space here, the compression, and if there are any systems activated like deduplication or whatever. And what I want to show you now is if you have created your storage pool, you can now add a network share. So for example, if you have Windows machines in your network, you usually will use a Windows share via the SMP protocol. So you can click on add here and create a new path that you want to store here. For example, this one here. You also need to create a new user to authenticate to this network share. And you can of course set all the different permissions, access control lists, and whatever as well. So this is really intuitive, it's very simple, and I think I don't need to walk you through all the different settings here, because some may be interesting for you, some maybe not. But what I think is really important are the snapshots, because this is really the best feature of a ZFS storage pool, because you can create snapshots of a current timestamp and then you can revert back to this previous state and restore files that, for example, have been deleted or have been changed. And you can of course create them all manually, but you can also set up a task for that, which is pretty comfortable. So select tasks here and go to periodic snapshot task, and then you can add another task here. For example, create a daily snapshot of our datastat store, and the lifetime of this should be 2 weeks. So then I'm able to revert back to any day within the last previous 2 weeks, even if I have deleted some files. So this is really great. And if you have not installed this on a virtual machine, because you can use TrueNAS also on a physical hardware and not run it as a virtual machine, you can of course run virtual machines with that. So there may be some arguments why you probably would replace Proxmox with TrueNAS, so maybe this is also an option for some people, but I really like the virtualization features of Proxmox and I definitely want to keep that running. So I want to use both systems at the same time, and running TrueNAS as a virtual machine is a great option to do that. Okay, so this is how you can virtualize TrueNAS on Proxmox and build a great NAS system with that. Personally, I haven't seen any downsides doing this. However, I'm still thinking of maybe upgrading my NAS system at some point and maybe get an external system with more capacity. I'm not sure whether it will be again a do-it-yourself build or if I get a NAS device from Synology or QNAP. Those systems are also very good, but still very expensive. For now, I'm totally fine with running this as a virtual machine at home, and if I need more space, I can just add more hard drives and expand the storage pool, of course. So I hope you enjoyed this video and this was helpful. Please tell me in the comments which system are you using to store your files in your home network. And yeah, thanks everybody for watching. I see you in the next one. Bye bye.